I will give you a bonus of me doing some of your exercises today because I feel so bad. Okay, I think we are now good to go. Oh, come on. Okay, they say when you are working online, ignore my timelines. When you're working online, sometimes you will have problems, challenges with technology. And today is one of those. Sometimes my PC just freezes because it's tired. It's been online for a very long time. Okay, so since today we're going to be doing normal distribution, I'm not going to go through all the things because I think in my introduction, while we were waiting for my screen to pop up, we discussed some of these things. So now I just want to go dive deep into the session because you guys decided not to also talk to me, not to chat to me and everything. So I'm also not going to do a small chit chat. So we're going to look first at how we standardize the distribution. And because this is Akalit, we're just going to dive deep into how we do those calculations as well. So at the end of this 30 minutes, which I think I'm not going to count 30 minutes based on when we were supposed to start, we're going to learn how to compute the Z-score, which is our standardized value of taking your X observation value and standardizing it into it becoming a normal distribution function. And that's what we're going to be doing. So since we're going to be standardizing the values in order for us to transform them into a normal distribution, just to give you a little bit of a background about what normal distribution is about, it's a belly-shaped curve. It is where your mean, your median are equal. And we know that from chapter 3, where we said it is symmetrical. Remember that. We did that in chapter 3. And we're going to use our X observation to try and fit them into this distribution. By doing so, it means we're going to be calculating what the mean is and what the standard deviation is of our value. But in this instance, you are going to be given those values. So the mean will tell you the distribution of the curve and where it's located. And then your standard deviation will tell you how is it flat or is it tall? It tells you the spread of this distribution as well. And also what you need to know is that if we change the value of our mean, the graph will just move from left to right. It will just move from left to right based on the value of your mean. But if we change the value of our standard deviation, the graph will move either up or move up and it becomes taller, or when we change it, it might become flatter as well. And that is based on how big your standard deviation is. If your standard deviation is one standard deviation, it will look like this. If it's 0.5, it will be like this, because then if this is our mean, a 0.5 will be half of that. So the distance between the mean and the edge of the graph will be different. And if it is 2.3, it will be just like this. Oh, sorry. If it's 2.3, it's not going to be too tall. It will be flatter. 2.3 means the gap will be wider. As you can see from there to there, the gap is wider. So, and that is what the standard deviation does. It increases the spread or decreases your spread. Okay, so then how do we change our X observation into a standardized distribution? By applying the Z-score, which then it is our X observation minus the mean divided by the standard deviation. Remember, in the question, they will give you what the mean is and they will give you what the standard deviation is. If they do not give you, you can calculate them. We've done them in chapter 3. The mean is the sum of all the values divided by how many there are. The standard deviation is the square root of your variance, which is the square root of the sum of your X observation minus the mean squared divided by how many there are, which is n minus 1. Oh, this is the population, so it will be divided by n, and that is your standard deviation. Always, we need to know that with the normal distribution, it is distributed with the mean of 0 and the standard deviation of 1. It does not mean that the population that we are looking at is 0 or 1, but what this says, it says for a distribution, which is a normally distributed distribution, it will be distributed with the mean of 1 and the the mean of 0 and the standard deviation of 1. So let's look at how we do this calculation. So if X is distributed normally with a mean of 100, so there they give us the mean, and the standard deviation, they give us the standard deviation of 50 Rand. What will be the Z value where X is equals to 0? And X will always be given in the question. And to get that, we just substitute the values. We know what our mean is, we know our standard deviation is, and we know what our X is. We just substitute into the formula. 200 minus 100 divided by 50 gives us 2. And this, if we have to interpret it, but it's not required for you to interpret the values as well. It says that X, when X is equal to 200, it shows that there is a 2 standard deviation above the mean of 100. And that's how you interpret this. It gives you just that differentiation. Okay, so let's look at this another example. Since I wasted most of your time, just to pay you back, I'm going to show you how to do some of the exercises, but it doesn't mean that I'm going to do all your exercises. So let's look at this question. It says, the scores of high school students on a national calculus exam were normally distributed with the mean of 86 and the standard deviation of 4. What is the score of students that will receive a high score of 75? So we need to calculate the Z-score for the X of 75. So we need to first go to the question and identify what we are given. We know that is the mean, that is the standard deviation, and this is our X. What is very important also is to read the question. So the question here is very easy, fairly easy. It says the mean is equals, the mean is of 87. So we know that we're working with the population. So the mean is 86. The standard deviation is 4. The Z-score of students will have a score of 75. Remember, your X value is always going to be in the question, and that is where the question mark is. So that will be your X. Our Z-score, because we're calculating the Z-score, is X minus the mean divided by the standard deviation. Our X is 75 minus our mean of 86 divided by our standard deviation of 4. You take your calculator and you start calculating. When we calculate, we have 75 minus 86 equals minus 11. Minus 11 over 4 and divide that by 4. The answer we get is 2.75, minus 2.75, and that is our Z-score. What I will say is some of this you need to keep them because later on we're going to use all these questions as well when we do the probabilities. So you must remember to work it out and keep the answers so that we don't have to repeat them again later on. And I lied when I said I will do all your exercises. There is your exercise. A score of high school students on a national calculus exam were normally distributed with the mean of 86 and the variance of 60. Now, you need to be very careful when you read the question. Remember, the formula is Z is equals to your X minus your mean divided by the standard deviation. This is the variance. Therefore, you need to know that your standard deviation is the square root of your variance. We learned this in chapter 3. So you need to know that. You cannot substitute the value of the variance into the formula. That is your exercise. And it's 2 minutes because it's so easy. Do we have an answer? Shakila says is 1. Have you all calculated it? Okay, let's see if we all calculated it and we get 1. So we know that that is the square root of 16. Not 4. I'm already in an answer mode. The square root of 16 is equals to 4. So our standard deviation is 4. Our mean, which is what we are given, and our x is 90. So it will be 90 minus 86 divided by 4, which gives us 90 minus 86 gives us 4 divided by 4 gives us 1. I will also at this point suggest that when you get an answer for the Z-score, always keep it at 2 decimals. And I will tell you just now why we need to keep it at 2 decimals when we do the probabilities. Your next other question, also 2 minutes, since it's also easy to do. And I know you will do it quickly and finish it. Do we have an answer? Do we have an answer? No answer. Okay, so since you guys decided not to talk to me today, you are boycotting me, it's fine. I won't boycott you since I started on the wrong footing today. So let's go. To answer this one, we know the formula is Z is equals to X minus the mean divided by the standard deviation. What we are given, we're given the mean of 86. The variance, we know that this is the standard deviation will be the square root of 16, which is equals to 4. We've done it previously. And our X is 80. So we just say 80 minus 86 divided by 4, which then gives us minus 1.50 if you calculate. And that's how you standardize the values. Any question? And I don't know why I'm asking any questions since you guys don't speak to me. Okay, we move on. Let's now learn how to calculate the probabilities now. Like when I started, I introduced and I said, we're going to standardize the values. We're going to look at how we calculate the probabilities, but also when we calculate the probabilities, we need to know how to calculate the probability when it is less than when it's more than or greater than, and when it is between. And this is where we calculate the probability of less than. And I also mentioned that we're going to be using the table, and the table has the positive and the negative side of the table. And the table that we're going to be using is called a cumulative standardized normal distribution table. So how do we then calculate these probabilities? As you can see, the probabilities, we calculate them by using the Z value, or we go find the probability. We don't normally calculate them, but we go find the probability by using the Z value. So it means we need to calculate the value of our Z and use that value, go to the table. Now, there are several things you need to understand about the probabilities we find for the normal distribution. The values of the probability, especially the belly curve, it does not touch the X observation anywhere, but we are able to calculate the probability underneath the curve, which is the area underneath the curve. So if we're calculating the probability of a less than, it means the table also contains the probability of a less than. Now, what you will notice, like I said, the table has the positive side and has the negative side. So let's say we're calculating the probability of Z less than A, and A is any number. So since A is positive in this instance, the area will be from the positive side. But if we're calculating Z less than and it is negative, then the area will start from the negative side. And that will be the area from this side and going that side. Because of that table. So the table, which I'm going to show you now, the value we're going to find when we calculate Z less than, when we calculate Z less than, it's going to always be the value on the table. And why I'm saying that, this is the table. It has the negative side of the table and the positive side of the table. If you look at this, so this is what we were doing there on the red. So that is our mean, and this is our mean. Remember, it's distributed with the mean of 0. That is our mean. So if it's positive, if A is positive, it will start in the positive side, but it will include all the negative side as well because it's positive. If it's negative, it will start in the negative side and includes all the negative. That will be a cumulative standardized normal distribution table. So I want to put here, it must say cumulative standardized normal distribution table. And it's table E2 for those who are doing STA1610 and 1510. So since the table looks like this and it's the cumulative probabilities, now you need to also understand the following. If you need to find the probability of an exact, you cannot use the cumulative standardized normal distribution because you're looking for that probability of exactly. There is a table for it, but it is not advertised, or you do not have to know about that in this module. Only when you do the stat stream, I think the higher one, I'm not sure if in the 1501 they do ask you to calculate the probability of exactly, but if they ask you, there is a table called the standardized normal table. It has the probability of exactly. Okay, but in your module, you're always going to calculate the probability of less than or greater than or between, which is not normally the probability of exactly, which is always, sometimes it will be equals to 0. Okay. So how do we then use the table to find the probability? So let's say, for example, I'm just going to use one of this that we used now. All of them are negative, positive. So we can use the positive one. So let's say we want to find Z less than 1,00. So to read the values on the table, I'm sure it's visible from your side. The first two values, the one before the comma and the one after the comma, we always find it on here. The last digit on the table, on the Z value, we always going to find it on the last digit at the top. So how we read this table is to take the first two digits and the last digit. So this we find it on the left and this will find it on top as a last digit at the top. You can see there, all the last digits are populated. And here you can see that it's a value before comma and the value after comma. So 1, 0, we find it here, which is that value. And 0, 0, 0, because the last digit is 0, we just go and look at the last digit is 0, and it means it's this table. Therefore, the answer will be 0, comma. So the answer for this one will be 0,8413. And that will be the probability of Z less than 1. That will give us 0,843. And that's how you will read the table. Only when the probability, when the question says, what is the probability of a less than? So let's look at an example in detail. Let X represent the time it takes in seconds to download an image from a file, from an image file from the internet. Suppose X is normally distributed with the mean of 18. Suppose X is normal with the mean of 18 seconds and the standard deviation of 5 seconds. Find the probability of X less than 18.6. So what they're asking is to find the probability of X less than 18. And we know that the mean in this instance is 18. So this is our mean. And we are told what our standard deviation is. And we know what our X is. And since it's the probability of the less than, when we calculate the Z value, the probability we find on the table will be our probability. How do we do that? We calculate the Z value. By substituting the value, we know that our mean was 18, our standard deviation was 5, and we know that in the question they asked us to find the probability of X is less than 86.6. And we substitute into the formula. 18.6 minus 18 divided by 5 gives us 0.12. As you can see, we moved from this normally undistributed value. We went to a normal standardized distribution table where the mean is 0 and the standard deviation is 1 at this point, with the Z value less than 0.12. How do we then go find the value on the table? Remember our Z table? We go to the positive side because this is positive. We go look on the right on the left for 0.1, on the right, on the left, and we go to the top, the last digit, we go find 2, and the last digit is 2. Where they both meet, that will be our probability. So the probability of X less than 18.6 is the same as the probability of Z less than 0.12, which is equals to 0.5478. And that's how we find the probability of a less than. Or I move on. Any question? If there are no questions, then let's do an exercise. I will do one exercise and I will give you time to do the other exercise. The owner of an appliance store uses a normal distribution with the mean of 10 and the variance of 9 to model the weekly net sales. Calculate the probability that X is less than 3.5. X is less than 3.5. So they're asking us to calculate the probability that X is less than 3.5. That's easy because we know from here, it means we're going to find the value on the table, regardless of whether it's negative or positive. The value we find on the table, that will be our probability. What else are we given? We know what the question is looking for. Z of less than X minus the mean divided by the standard deviation. So I need to identify what we're given. The mean, we're given 10. The variance, which we need to calculate the standard deviation from, which is equals to, what is the square root of 9? The square root of 9 is 3. So our standard deviation is 3. Now we can go and substitute. We know the X is in the question. So the probability that Z is less than 3.5. So we're calculating what is inside the bracket. 3.5 minus the mean of 10 divided by the standard deviation of 3. And this gives us the probability that Z of less than 3.5 minus 10 gives us minus 6.5. Divided by 3 gives us minus 2.17, because we need to only keep 2 decimals. Minus 2.17. And since it's 2.17, then we can go to the table. I'm going to use the table we have here. I hope it has all the values. Oh, shit. It's hidden. All the values are hidden. Okay, I will have to go open a table with all the values and then share it with you now. I'm going to use, okay, let's stop sharing that. And share the normal distribution table. Those who joined late while I'm still talking, please make sure that you write your student number in the chat. We don't have the timetable, the attendance register functionality anymore. Okay, so we need to look for table E2. There we go. This is our table. Make it bigger so that everybody can see. We know that we're looking for 2.17. Remember that? Our Z of less than minus 2.17. And this is the negative side of the table. So here we're going to look for 2.1. And that is minus 2.1. And we need to go to the top to look for 7. I like to do it this way because then I can't see where I am. I hope that is 7. This is 7. And that probability is 0.015. 0.0150, and that is the probability how we find the probability. Okay. Any question? If there are no questions about the table, then we can go back to our presentation. Okay, so we go back to our question. We find that that probability was 0.0150. Your exercise.
Your audio is mute.
Oh, shit. I am muted. And my volume, I think it was low. Can you guys hear me? Ah, probably you were talking to me and my mic is muted, and I am so sorry. I will go back and repeat what I just said. We calculated this earlier. We find that 80 minus 86 divided by 4 was minus 1.50. So to find the probability of Z less than minus 1.50, we go to the table and we find that it is 0.0668, where we find minus 1.5 on the left and 0 at the top. Where they meet, that was the answer. That's what I said. Coming to exercise 3. I also said we calculated it previously and we used it as an example when we were looking at the table and understanding the table, and we said to find the probability that Z less than 1.00, we went to the table and we found that it was 0.8413. Remember that. Any question? If there are no questions, then let us move on to how we calculate the probability of a greater than. So far we've been doing the probability of a less than. So how do we then calculate the probability of a less than? And that's what we're going to be doing. We're going to find the probability of Z greater than a value. And this same way, since we're looking at the positive A and it's greater than, therefore it will be on the positive side greater than, all the curve underneath the area underneath the curve. The challenge with this is, since the table contains the probability of less than, both the positive and the negative contains the probability of a less than. And we know the sum of all probabilities should be equal to 1. So since that we know, therefore it means the table contains the complement of a greater than, which means if we need to find the probability of a greater than, we have to subtract the value we find on the table from 1. And that's what we are going to be doing. For all the question that has a greater than, we're going to subtract the value we find on the table from 1, whether from the positive or from the negative is subtracted from 1. How do we do that? Like the following. Suppose X is normally distributed with the mean of 18 and the standard deviation of 5. Find the probability of Z of X greater than 18.6. Some of these things we did because it's the same example we used for the less than, so I'm not going to go into detail on how we calculate this. So I'm going to just show you after you calculated your Z values, you get the probability of 0.18. Remember that we calculated it when we did the first example. Therefore, because we're finding the probability of a greater than, we need to go find the probability of Z less than on the table. So we go to the table, and I know we went to the table, we found it, and it was 0.5478. We subtract that probability we find on the table from 1, and the answer will be 0.4522 for the probability of Z greater than 0.12. Another example, the high school student on the national calculus, blah, blah, blah. We know we calculated this previously. I'm not going to go too much into detail on this. Remember, we go find the probability that Z is greater than X minus the mean divided by the standard deviation, which we will find by using 1 minus the probability that Z is less than or equal to X minus the mean divide by the standard deviation. And we calculated this because I'm not going to go into details about it, because it was one of the exercises that we did, and we found that the probability that Z is less than minus 1.50. We calculated it, remember that. And we went and found the probability on the table. I'm not going to go too much into details because now I'm going to take shortcuts. We went and we found that that probability was 0.0668. Remember that. That's the same question we've been doing. It was 0.0668. So we went and found that probability. We can then substitute that probability onto 1 minus 0.0668. And that will give us 1 minus 0.0668 gives us 0.9932. That is the probability of Z greater than 80. Sorry, Z greater than minus 1.50. Sometimes in the exam or some of the questions, you might be given a question like this. Already they've calculated your Z. All what you need to do is to go find the probability on the table. Remember, the question is greater than. Therefore, it means you're going to have to say 1 minus the probability you find on the table, which is of the probability of Z minus 2.88. So go to the Z table and go find minus 2.88. And to find that value of minus 2.88, okay, I hope you went and found that probability. It is minus 0.0020, and therefore the answer will be 0.9980. And that will be option number 4. Happy? Any questions? Are you happy? Absence of questions, we can do another exercise. Suppose X is normally distributed with the mean of 100 and the standard deviation of 20. What is the probability that X is greater than 145? Okay. So we want to find the probability that X is greater than 145, which is given by the probability that Z will be greater than the X minus the mean divided by the standard deviation. But we know that we have to find 1 minus the probability that Z is less than our X is 145 minus our mean of 100 divided by our standard deviation of 20, which is 1 minus the probability of Z is less than 2.25. When we go to the table, as for the last time, for those who still don't know how to get there, let's show you the table because I know that I am rushing. So you go to the cumulative normal standardized distribution table, which is table E2 of the cumulative standardized distribution table. We're looking for 2.25. We go to the positive side because the answer is positive. The first 2 digits, we find it on the left. The last digit, which is 5, we find it on the table. Since I'm going to scroll, I've already highlighted the column so that I don't miss the values. And this is 2.2 and 0.05. The probability is 0.9878. Once we have found that probability, then we substitute into the formula. We substitute into the formula 1 minus 0.9878, and this will give us 0.0122, which is question number 4, answer number 4. I hope I am right. When you answer questions like this, please be careful not to select the 3 because it looks almost like the same as that one. It's just that that one is 0.12 and the answer is 0.0122. Next, last question. Find the probability of X greater than 17.5. Okay, so we need to find the probability of x greater than 17.5, which means we can find the probability of z greater than 17.5 minus 10 divided by 3, which is the same as finding the probability of 1 minus the probability of z less than. If I calculate all the answers that are in there, I will find 2.50, which then I go to the table and I find that it is 1 minus 0.9938, which gives me 0.0062. Any question? No questions? Please remember those who came in late to write your student number on the chat so that they can keep register of how many students have attended the session. Okay, so now let's move to the last part, calculating the probability of the between. Therefore, it means we're going to be calculating the probability that z lies between the two values. And since it lies between the two values, then we're going to do it different ways. So when z lies between the two values, it means we only calculating this portion, which is very difficult to calculate if you don't know how to do that. Remember, the table, we're going to use the table value. The table value contains the values of greater than, which are those values going that side. So therefore, for us to find the probability of the greater than, since z is less than b, means we are able to find this probability by using only z less than b. So we can get the value from the table for this area of less than b. Then we need to go find the area of z greater than b, which is 1 minus. We will always go and say 1 minus. We don't have to say 1 minus. We can just find the value we find on the table for z less than b and subtract it from that. So we're going to say the probability of z less than b minus the probability of z less than a. And then we go find both of those probabilities and subtract one from the other. And that's how we do. So we first go find that one, then we go find this one and subtract one from the other. I hope you understand. You first have to go find the probability of z less than b, regardless of whether it is in the negative or the positive, doesn't matter. You first find the probability of z less than b, then you go find the probability of z less than a, even though here it says z is greater than a, but you go find the probability of z less than a. And when you find both of those, subtract one from the other. Let's look at an example to make things easier. Suppose x is normally distributed with the mean of 18 and the standard deviation of 5. Find the probability that x lies between the two values, 18 and 18.6. So we calculate the z value and the z value. So which is the same as calculating the probability of the Z values. And once we've calculated the probability of the Z values, that will be your probability. Then we go to the table. We go to the table. After we find the probability of the Z value, remember, we're going to find this probability first, and that is why I split it into the probability of Z less than 0.12. And then we go find the probability of Z less than 0. We go to the table, find the probability of Z less than 2, which is 0.5478. Then go find the probability of Z less than 0, which is 0.00. So which will be equals to 0.5. Substitute into the formula, and we find that that probability of between is just 0.478. And that's how we calculate the probability of between. Looking at another example, find the probability of Z or of X lying between 17.4 and 18.0 or 18. Suppose X has the mean of 18 and the standard deviation of 5. So now we need to find the probability of this area. We go find the Z values, we calculate them, and we find that the, let's skip that part. Let's go back there. Let's go calculate the Z equals 17.4 minus 18 divided by 5. And when we calculate this Z, we find that it is 17.4 minus 18 equals minus 0.6 divided by 5 equals minus 0.12. Then we also do the same, Z equal or Z less than or equal, it doesn't matter for this purpose. 18 minus 18, because our mean is 18, divided by 5, which is equals to 0.00. So if we go back and substitute into the formula, we will be finding the probability that Z lies between 0.00 and minus 0.12. That's what we are finding. Now it means we need to go find the probability that Z is less than minus 0.12 minus the probability that Z is less than 0. So when you go to the table, and find the probability of Z is 0, you go and find it, it's 0.05. And we go find the probability of Z is minus 0.12. We go find it, and it will say it's 0.54522. When we subtract both of them, we get the probability will be equals to 0.478. If there are no questions, I am going to give you an exercise to do. So here they also calculated the Z values, so you don't have to calculate them. You just use the values you see. So just to give you a hint, you just use the probability of Z less than 1.190 minus the probability of Z less than minus 1.10. Use those values, go to the table, find the probability of each one of them. Okay, so if we go to the table, we will find that Z of less than 1.90 is 0.9713 minus, when we go to the minus 1.10, we find that it is 0.1357. And therefore, when we calculate this, we get 0.8356, which is option number 3. Your next exercise, I think from now on, we just do exercise after the other until the session is ending at the end of Okay. Seems like you guys understand this part. You all are getting everything right. So we need to find the probability of between. So we find the probability that X lies between two values, 71 and 82. And this we can find it by finding the probability that Z lies between 82 minus our mean of 76 divided by our standard deviation of 10 minus the probability, because this is the same as finding the probability, the probability that Z lies between. We substitute the values of X minus the mean divide by the standard deviation, and you do the same this side. And here I'm just going to extra step of splitting the two and say we start with the 82 first, and then we're going to the Z of 71 minus 76 divided by the standard deviation of 10. And that will give the probability that Z lies between the two values, which then if we calculate for 82 minus 76 divided by 10, we get 0.60 minus, if we calculate 71 minus 76 divided by 10, we get the probability that Z lies between that, which will be minus 0.5. If we go to the table to find 0.06 on the positive side of the table, we find 0.7257. Minus, if we go to the negative side to look for minus 0.50, we find 0.3085. Therefore, that 0.7257 minus 0.3085 is 0.4172. Okay. I think this will be the last question, and then we'll be done for the day.
How do you know which value is A? Is supposed to represent A, or which value is supposed to represent B? Because when it comes to the last part, I did 0,3085 minus 0,7257 instead of 0,7257 minus 0,3085.
Okay, so always this is A, that is B, because it's between the two values. And that is what, if you look here, I will substitute there 71 and I will substitute here 80, 82. And since I know that I have to do this first part, I did it this side first. You must always do the B side first, which is the last value first. So
Okay.
that's our B. Our A will be the first value. So the smallest value will always be our A. The largest value will always be your B. So if we look at the question that we have now, when you ask the question, I immediately put the A and B because it lies between the two values. It lies between A and B, 80 and 90.
Okay. No, thank you.
Okay, so this one should be easy because we did calculate the values earlier on during the session. So the probability that X lies between, let me write it on top because then I will run out of space. Calculating the probability that X lies between 80 and 90. We will calculate the probability that 80 minus 86 divided by the square root of 16 is 4. We did calculate that, which will be Z. 90 minus 86 divided by 4. Then we can get the answers. 80 minus 86. This is 86. 80 minus 86, we found that it was minus 1.50. And since we're doing the probabilities of Z, no, what am I doing? Minus 1.50, which is less than Z, less than, and we do the same this side, 1.00. And here we can find the probability that Z is less than, we do this side first, 1 minus 1.00 minus the probability of the second side, which is Z less than minus 1.50. When we went to the table, we found the values. For 1, the value was 0.8413 minus the value we found for minus 1.5 was 0.0668, which then when we calculate, we're going to find that it is 0, what is the answer we get? I don't think we have the answer on there. 0.8413 minus 0.0668 equals 0.7745.
I got that answer as well.
I think this was an errata here. It should be
745.
It should be like that. And that concludes today's session. Any question before I recap? Remember, in the exam, they might give you the Z already calculated, or they might ask you to calculate the Z and find the probability. So you need to know how to do both. Just to recap on what we did, we looked at how we calculate the probabilities, especially how to first standardize the distribution by using the Z-score, and then calculated the probability of Z less than the value, which we find on the table, and we calculated the probability of Z greater than the value, which we find, let me write it here. So we know that we find the probability of Z less than a value from the table, and we'll go find probability of Z greater than the value. We find it 1 minus the value we find on the table, and the probability of between, which is Z, lies between two values, A and B. We go find it by using the probability of Z less than B minus the probability of Z less than A, which means we go find the value on the table for B and go find the value for B and subtract one from the other. And that will be your Z less than. And that's all what we did today. Any question? If there are no questions, so I'm going to give you 15 minutes early. As much as I spent 15 minutes ignoring you online, I'm also giving you 15 minutes break time. Otherwise, thank you guys for joining the session and for participating on the chat. I will see you next week when we discuss sampling distribution, and I think we will do both sampling distribution and confidence interval. Remember, we need to catch up on one of the Thursday we didn't have a class, so we are one session behind. So next week we'll do 2. The first hour we will do sampling distribution, which also it's almost like exactly what we have been doing today. So we should not even spend more time there as well, because it will be things that we already learned. And then we will do the confidence intervals. Thank you very much for coming through.
Thank you. Bye-bye.
Bye.